If there is a hole that humans have ever drilled into the earth, what is underneath? Lava, mysterious creatures, or something that science has never predicted? Today's story will take you to the bottom of the world, where humans have tried to penetrate the planet's crust to discover secrets that have been buried for billions of years. But the most surprising thing is not the depth. It is what they found, discoveries that left the entire scientific community speechless. And the real reason why this project had to stop forever, not everyone knows. Watch until the end of the video to discover 3 secrets that have never been widely publicized about the world's deepest borehole. And if you love mysterious content, science, and exploring the world in ways that no one has ever told, don't forget to follow the channel so you don't miss any journey to the limit with us. During the Cold War, a period when the confrontation between the US and the Soviet Union extended from military to scientific, not only outer space but also the Earth became a battlefield of technological competition. After the US successfully launched the Apollo 11 spacecraft to put humans on the moon in 1969, the scientific prestige of the United States was pushed to the highest level, forcing the Soviet Union to find another way to demonstrate its intellectual power. And so, they decided to carry out an unprecedented project in human history, drilling the deepest hole ever made by humans, directly into the Earth's crust. The goal of the project was not to exploit oil or gas like conventional commercial drills, but to access the Earth's oldest geological layers, conduct research on the structure of the Earth's crust, the process of planet formation, and even search for traces of life in the past. This was seen as a symbolic scientific journey. If the US could reach the moon, the Soviet Union would reach the Earth's core. The project, called the Kola Super Deep Borehole, was launched on May 24, 1970. It was no coincidence that the Soviets chose the Kola Peninsula in northwestern Russia as the site for the construction. This is an ancient land, estimated to be over 3 billion years old, and one of the oldest rock formations on the planet. Drilling deep here meant being able to penetrate dozens of geological layers that had accumulated over time, opening up the opportunity to reconstruct billions of years of our planet's history through analysis of sediments and rock structures. The initial strategy was clear. The Soviet Union wanted to be the first country to penetrate the Earth's crust, crossing the technical and scientific boundaries that no one had ever reached. Not only was it a technical feat, it was also a political and symbolic move. If the US dominated the skies, the Soviet Union would dominate the underground. In an era where every achievement was tied to institutional competition, going deep into the Earth's geology also had the value of a conquest of invisible territory, where the primordial secrets were still buried deep under the hot rocks and terrible pressure. This project not only demonstrated ambition beyond limits, but also demonstrated a strong belief in science, regardless of harsh geological conditions or limited technology. It was a time when scientists were not afraid to challenge the unthinkable, and the underground became the final frontier. Since then, the name Kola Super Deep Borehole has become a scientific symbol, a silent declaration that humanity not only looks up to the stars, but is also ready to face the depths of the Earth, to learn about itself. The choice of location for an unprecedented deep drilling project in human history was not a random decision. After many thorough geological surveys and assessments, Soviet scientists decided to choose the Kola Peninsula, located in the northwest of Russia, between the Arctic and White Seas. This is not only a wild, sparsely populated land, convenient for construction, but more importantly, it has an ancient rock foundation formed more than 3 billion years ago, one of the oldest geological formations on the planet. That is what makes the Kola Peninsula an ideal time gate to drill deep down and trace back to the Earth's past. On May 24, 1970, the first drill bit was officially lowered into the ground. In the first stage, the engineering team used commercial drilling equipment used in oil and gas exploitation, such as the Uralmash series drill. Thanks to the stable geological structure, The initial drilling speed was quite favorable. In just 4 years, they reached a depth of 7,000 meters, a figure that far exceeded most civil and commercial drilling projects at the time. However, the deeper they went, the more technical challenges became apparent. Traditional drilling equipment was no longer able to withstand the increasing pressure and temperature. That was when scientists were forced to upgrade the entire system. In 1974, a new drill designed specifically for this purpose was put into use, the Uralmash 15,000. The number 15,000 is not accidental, but represents the maximum depth that the device was expected to reach, 15 kilometers. This was one of the most advanced drilling machines at the time, reinforced to withstand heat, pressure, and precise drilling in harsh underground conditions. Thanks to the new equipment system, the drilling continued. On June 6, 1979, the Soviet Union officially broke the world record for the deepest drilling hole previously held by the United States, with the Bertha Rogers well, 9,583 meters. But instead of stopping at the record, Soviet scientists continued to go down. By 1982, the drill bit reached a depth of 11,762 meters, and less than 2 years later, they reached the great milestone, 12,262 meters, making Kola the deepest man-made borehole in human history to this day. However, this journey was not entirely a straight line. Instead of drilling straight down from the surface, engineers applied the branching strategy. From deep points such as 9,300 meters or 7,000 meters, they created auxiliary drill branches at an angle, both avoiding difficult rock layers and reducing pressure on the main drilling system. This approach makes the project more flexible, although it still faces numerous technical risks. There have been times when tens of meters of equipment have broken off and fallen into the ground, blocking the entire system, forcing the drilling process to be suspended for months while it is handled. What is amazing is that despite countless challenges, from geology to weather, the project has continued to persevere over the years. Each meter of drilling is not only a technical step forward, but also a layer of the Earth's past that is peeled away. Each layer of rock, each sedimentary fragment that the drill touches is a clue that helps humans reconstruct the history of the formation of this planet, from the time before life to the time when the continents began to move. The Kola project is not just a scientific endeavor. It is a testament to the spirit of conquering human limits. In an age when records were a measure of authority and power, drilling into the Earth was as symbolic as reaching the moon. And with Kola, the Soviet Union carved its name into a milestone that no one would easily surpass. The record for the deepest man had ever drilled into the Earth, a space feat, but directed downward. The Kola project was not only a journey to explore the depths of the Earth, but also a relentless battle against technological limitations and unprecedented technical failures. Despite achieving impressive milestones in depth, the deeper the project went, the more obstacles it faced that almost brought everything to the brink of collapse. One of the most serious incidents occurred in 1984, when the auxiliary drill created at a depth of 9,300 meters began to approach the 12,000 meter mark. Suddenly, a multi-ton, 5-meter-long part of the drilling system twisted and broke at a depth of 5 kilometers. This not only blocked the entire well, but also made the process almost impossible to continue. When such a heavy equipment was stuck at such a terrible depth, no technology at that time could bring it up safely. Scientists were faced with two risky choices: either abandon the project or drill a new branch, which would take time, cost money, and potentially have greater errors. While the Soviet Union had not yet fully recovered from this incident, the catastrophic event at the Chernobyl nuclear power plant in 1986 dealt a heavy blow to all scientific activities in the Soviet Union, including the Kola project. In the context of tight budgets and declining public confidence in large technological projects, continuing to dig deeper became a burden both financially and politically. From here, the project entered a series of unstable years, drilling, stopping, switching branches, and stopping again. In 1990, when the third drill, which had reached a record depth of 12,262 meters, failed, the research team was forced to abandon this branch entirely and start drilling the fourth branch from the turning point at a depth of 9,653 meters. However, this branch only extended to 11,882 meters before suddenly stopping in 92 due to unknown causes. Although no details were released, many analysts believe that the cause came from the phenomenon of extreme temperatures and pressures exceeding the tolerance of the equipment. One of the biggest shocks to the scientific community was the difference between predicted and actual temperatures at such great depths. Initially, they calculated that at 12 kilometers underground, the temperature could fluctuate around 100 degrees Celsius, a number that was within the allowable range of new generation drilling equipment. But the reality was much harsher. The measured temperature reached nearly 180 degrees. Under such conditions, metal parts began to deform, the lubrication system lost its effectiveness, and the drill bits became brittle and more prone to breakage. Many times, the drill pipes broke or became clogged due to the molten rock deforming like plastic, making further drilling almost impossible. Despite facing numerous technical difficulties, the Kola Super Deep Borehole project still left an extremely valuable scientific legacy. What was discovered underground at a depth of more than 12,000 meters not only amazed the scientific community, but also re-established a series of fundamental assumptions in the field of geology. This is no longer a well, but a door opening billions of years of Earth's history. The first discovery of timeless value is the access to an ancient rock layer dating back 2.5 billion years, belonging to the Precambrian period. This is equivalent to humanity creating a time machine, allowing us to go back in time to reach the times when multicellular life had not yet formed. The rock fragments brought up from a depth of 12 kilometers contain traces of the Earth's crustal tectonics, stratigraphic changes, and even the movement of continental plates. Studying these layers of rock allows scientists to reconstruct the climate, atmospheric composition, and structure of the planet over billions of years, something that cannot be done with pure modeling. Not stopping there, the second discovery forced scientists to rewrite textbooks. Groundwater exists at depths of 3 to 6 kilometers in cracks in the hard granite layer. Previously, the scientific community believed that at such depths, the high pressure would make it impossible for water to exist stably, or if it did, it would be pushed back to the surface. However, Kola's drill proved otherwise. Not only did the water not evaporate or be forced to rise, but it also existed in a stable liquid state under extreme pressure and heat. This discovery opened up the hypothesis that there may be ancient lakes in the Earth's interior that were never known, even a potential environment for microbial life deep underground. The third discovery was even more exciting: the presence of hydrogen and other light gases at a depth of tens of kilometers. During the drilling process, engineers noticed that the drilling mud was bubbling, as if boiling. But this was not due to temperature. It was due to extremely high levels of compressed hydrogen gas escaping from the ground. This shocked the scientific community because, according to theory, light gases such as hydrogen or helium do not last long in the Earth's environment because gravity is not enough to hold them. So why are they still trapped underground billions of years later? The answer lies in the Earth's formation process itself. Scientists speculate that when the Earth was still a molten mass of magma, some of the original hydrogen gas was trapped inside deep pockets of rock. The Kola project inadvertently reactivated a gas reservoir from the planet's formation. This opens up new directions in research on the origin of the atmosphere and clean energy in the future. Not stopping there, Kola also recorded the phenomenon of rock layers at great depths no longer maintaining a solid state, but starting to show signs of being flexible like hot plastic. This change in physical state proves that deep underground, rock is no longer a stable material, but becomes a living element, capable of moving, distorting, or sealing wells. This makes the study of the dynamics of the Earth's crust much more complicated than previously assumed. All of the above discoveries have completely changed humanity's perception of the structure and conditions inside the planet we live on. Kola is not just a deep drilling project. It is the only geological observatory that can reach rock layers that have not been exposed for billions of years. Thanks to that, models of planetary evolution, geological movements, the possibility of underground water, and ancient gas sources must all be updated. Despite reaching an unprecedented depth of 12,262 meters, the Kola Super Deep Borehole project was eventually terminated, not because the well had achieved its goal, but because of a series of vital reasons that made it impossible to continue. This was not just a technical or financial failure, but a clear reflection of the greatest limitations that science and humanity face: resources, technology, and the complex nature of our planet. The first and most obvious reason was the collapse of the Soviet Union in 1991. From the late 1980s, the Soviet economy began to sink deeper into crisis. The state budget was increasingly tight, causing scientific projects that did not directly serve the military or national security to be drastically cut. The Kola project, although once a source of pride, was no exception to that rule. All operating costs for drilling equipment, system maintenance, and specimen research were suspended. In a country on the verge of collapse, a well tens of kilometers deep, no matter how great, would be just a forgotten name among the ruins of an entire political system. But if it were only financial factors, Kola could have been continued in a reduced form or transferred to another scientific organization. The problem was that even with the money, people at that time did not have enough technology to drill deeper. The drilling equipment was deformed by high pressure. The pipes were broken by extreme temperatures, and the rock at great depths had turned into a plastic state, no longer stable enough to hold the shape of the well. When drilling deeper, instead of going through the solid rock layer as expected, the drill bit encountered flowing rock layers, like hot clay, causing the well to be continuously blocked, creating uncontrollable risks. Another particularly dangerous factor was that the actual temperature was more than twice as high as predicted. Instead of around 100 degrees as the initial calculation models, the measuring devices recorded a temperature of 180 degrees at a depth of more than 12 kilometers. In such an environment, the metal began to expand unevenly, the lubricant lost its effectiveness, and the ability to control the drilling direction became almost impossible. Electronic tools could not operate stably either. These factors created a technological wall that Soviet scientists at that time did not have the capacity to overcome. Not only that, the deeper we went, the more unstable the geological environment became. The presence of high-pressure hydrogen gas, unstable groundwater, and boiling drilling mud increased the risk of losing control of the well. Continuing to dig deeper could lead to dangerous fluid eruptions or even underground gas explosions. In the absence of adequate technical conditions, any attempt to go deeper would have potentially catastrophic consequences, not only for the equipment, but also for the lives of the construction team. Ultimately, what officially brought the project to an end was that the scientific value was no longer commensurate with the risks and costs. After reaching the 12 kilometer mark, the new discoveries began to lose their groundbreaking quality. Drilling a few hundred meters further would not open up completely new strata, but would only reach similar layers of rock under more severe conditions. In other words, the costs of going deeper were exponential, but the benefits were only additive, not convincing enough to continue investing or deploying improved techniques. In 2005, all the facilities at Kola, from the research building, drilling equipment to the operations center, were dismantled. The project was closed quietly, without a farewell ceremony, without a grand declaration. Only a rusted metal cap remains on the surface, marking the site of what was once the world's deepest man-made borehole. The Kola Super Deep Borehole is finished, But what it leaves behind is more than just a dent in the Earth's surface. It also raises a big question mark for the future. Can humans really reach the Earth's core? Or have we reached the limits of our capabilities? The answer is still unclear, but one thing is certain. The journey to the depths of this planet will always be one of humanity's greatest challenges. What do you think about this project? Will humans ever drill to the core of the Earth? Or is it just a pipe dream in front of the majestic nature? Leave your opinion in the comments section. And if you love scientific exploration content like this, don't forget to subscribe to the channel so you don't miss the next videos.